Hi there! Having trouble with your chemistry class? Well, worry no more. We are gonna help you with it. I am gonna teach you about hydrocarbons. What is a hydrocarbon? Hydrocarbons are organic compounds that are made of only hydrogen and carbon atoms. They are found in many places, including crude oil and natural gas. Learn the different forms of these simple yet varied organic compounds. Again, a hydrocarbon is an organic compound made of nothing more than carbons and hydrogens. It is possible for double or triple bonds to form between carbon atoms and even for structures, such as rings, to form. There are two types of hydrocarbons, the aliphatic or open-chain compound and the cyclic or the closed-chain compound. There are two types of aliphatic, the saturated and unsaturated. Aliphatic hydrocarbons are compounds of hydrogen and carbon that do not contain benzene rings. We'll discuss compounds with benzene rings later in this lesson. Aliphatic hydrocarbons tend to be flammable. Okay, for its two types, it has saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons have as many hydrogen atoms as possible attached to every carbon. For carbons on the end of a molecular chain, 3 can be attached. For carbons in the middle of a chain or a ring, 2 can be attached. For a carbon atom all by itself, 4 hydrogen atoms can be attached. Saturated hydrocarbons have only single bonds between adjacent carbon atoms, while unsaturated hydrocarbons have double and triple bonds between some of the carbon atoms. There are several types of aliphatic hydrocarbons: alkanes, alkenes, and alkynes. Let's start with alkanes. Alkanes are linear or branching compounds that are made of varying numbers of carbon atoms that are all saturated with hydrogen atoms. The general formula for an alkane is CnH2n plus 2. This means that the number of hydrogen atoms equals twice the number of carbon atoms plus 2. Alkane. Alkane has a general formula of CnH2n plus 2, and we use Ane as its suffix. Okay, if we have one carbon of alkane, we have its molecular formula is CH4, and then its expanded structural formula looks like this, while its condensed structural formula looks like this, and it has no length formula since it has only one carbon. Okay, for 2 carbons of alkane, we have its molecular formula of C2H6, which means 2 carbons and 6 hydrogens, and its expanded structural formula, it looks like this, and its condensed structural formula looks like this, and it has 2 carbon line formula because it has 2 carbons, which is 1 and 2. 1 and 2. Next, we will discuss about alkenes. Alkenes are like alkanes, but they have at least one double bond between carbon atoms. The formula or general formula for an alkene is a little trickier, since the number of double bonds may vary. An alkene with only one double bond has the general formula of CnH2n. Each double bond means fewer hydrogens than a corresponding alkane. For each additional double bond, subtract 2 more hydrogens. The simplest alkene is ethene, with a formula of C2H4. Alkane, which has a general formula of CnH2n, and we use Ene as its suffix. For if we have 2 carbon of alkene, we have a molecular formula of C2H4. And then its expanded structural formula looks like this. And its condensed structural formula looks like this. And its line structural formula is this, since it is a double bond. And for if it has 3 carbons, its molecular formula is C3H6, and its expanded structural formula looks like this, and it has a double bond. And then its condensed structural formula looks like this, and its lines or structural formula is this, since it has a double bond. That's all. Last in our list of aliphatic hydrocarbons are alkynes. Alkynes have at least one triple bond between carbon atoms. The formula for an alkyne is variable as well. An alkyne with only one triple bond has a general formula of CnH2n-2. Each triple bond means 2 fewer hydrogens than a corresponding alkane. For each extra double bond, subtract 4 more hydrogens. Again, alkynes has a general formula of CnH2n-2, and we use YNE as its suffix. So, if we have 2 carbons of alkyne, we have a molecular formula of C2H2, and we have a expanded structural formula that looks like this, and its condensed structural formula looks like this, and then its line formula is this, since it is a triple bond. And if we have 3 carbons of alkynes, its molecular formula is C3H4, while its expanded structural formula looks like this, and its condensed structural formula looks like this, and it has a line formula of this. Remember that any number of carbon has a prefix name. As we discussed earlier, that every alkane always ends with a suffix ane. For example, there is one number of carbon atom, its prefix is meth plus the suffix ane. Therefore, one number of carbon atom is methane. 2 number of carbon atom is ethane. 3 number of carbon atom is propane. 4 number of carbon atom is butane. 5 number of carbon atom is pentane. 6 number of carbon atom is hexane. 7 number of carbon atom is heptane. 8 number of carbon atom is octane. 9 number of carbon atom is nonane. And 10 number of carbon atom is decane. And as for alkene and alkyne, there is 1 methene, methine, 2 ethene, ethyne, 3 propene, propyne, 4 butene, butyne, 5 pentene, pentyne, 6 hexene, hexyne, 7 heptene, heptyne, 8 octene, octyne, 9 nonene, nonine, 10 decene, decyne. Since we discussed about the first type of hydrocarbon, which is the aliphatic, or also known as open-chain compound, we will now proceed to the second type of hydrocarbon, which is the cyclic, or also known as closed-chain compound. And under this compound is the aromatic. What are aromatic compounds? Take a moment and think of substances that have a strong fragrance. What kind of things come to your mind? Perfume, vanilla, or perhaps even cinnamon? All of these are fragrant or aromatic. So what are aromatic compounds? Aromatic compounds are substances that consist of one or more rings that contain alternating single and double bonds in its chemical structure. In real life, many aromatic compounds have an odor. However, there are some compounds that are chemically aromatic but do not have a distinct smell. For example, is benzene. Benzene is an aromatic compound. The chemical structure of benzene, as illustrated here, contains a hexagon ring with alternating double bonds. Here you'll see there are two ways to draw benzene, structure 1 and structure 2. Structure 1 shows all the carbon and hydrogen atoms bonded together, while structure 2 shows a hexagon with alternating double bonds in structure. The edges of the hexagon are the carbon atoms, and the hydrogen atoms are not shown. Have you ever smelled paint or paint thinners? The strong smell of these products is due to the presence of a aromatic compound called toluene. Similarly, mothballs are very strong smelling because they contain an aromatic compound called naphthalene. Looking at this diagram, you'll notice the chemical structures of the compounds toluene. You'll note that they both contain rings with alternating single and double bonds in their chemical structure. So this is an example of toluene, or you can call it as methylbenzene. And that is all for hydrocarbons. Hope you learned something, and that's all. Thank you.